everyone is aware, we are recording, and just so that you know, if you have your camera on or say something during this call, it is going to be recorded, and it is going to be going up on the Electric Coin Company's YouTube channel. So just giving the disclaimer there. And welcome to the Zcash Arborist call. Today's date is March 9th, 2023. And yeah, excited to be with everybody today. This call is hosted by myself, Ian Zcashd from the Electric Coin Company. So the agenda for today's meeting is we'll have the welcome meeting intro, an update on the Arborist call hosting situation, and then we'll go through our normal agenda of Zebra updates, ECC core updates, research and implementation status, discussions, and then we'll wrap everything up and finish up from there. I'll just give a quick update on the hosting situation. We're currently looking for not a new host, but I'm working with a number of different members of the community to ensure a good handoff for the Arborist call. I announced last week that I'm leaving the Electric Coin Company as of next Wednesday. So the person hosting this meeting will be changing over the course of the next few months into going through the rest of the year. But I imagine that the rest of like the call infrastructure, the call links, everything of that nature should remain in place. We're just working through that right now to ensure that. So we'll have some updates on that within the next few days. So just want to provide an update there. Yeah, Nathan, go ahead.
Yeah, I just wanted to make sure we, if we're transitioning hosts, we, find someone that we're all comfortable with here in this meeting. So I'd like to follow up with you on that more after this.
Yeah, for sure. And if anyone has any questions on that, feel free to shoot me a message in Discord or shoot me an email. And yeah, Nate, I'll message you directly so we can sync on that.
And thank you, Ian, for all your work for ECC.
I appreciate that. Thank you.
Definitely.
Thank you. Awesome. So we're going to go ahead and just cover really quickly what the Arborist calls are. They are bi-weekly calls where everyone that is working on the Zcash protocol can convene to discuss upgrade timelines, process, protocol R&D efforts, design and implementation for new features, and then we can all work together to identify blockers and unresolved issues. And I don't know why my mouse isn't working today. The purpose of these calls is to make the core Zcash protocol development accessible for a wider set of participants and provide more transparency to the community at large. And then who can participate? Any member that is interested in participating on the Zcash protocol development can register for the call at electriccoin.co/events. We have all of the Arborist calls for the rest of the year listed there. And if you want to present an in-depth agenda item relevant to the Zcash protocol, please contact Janie at electriccoin.co for the time being. So this will probably be within the next week. If you would like to request a presentation slot. And then after we figure out who's going to be hosting the remainder of these calls, we'll change that contact email to the person or organization hosting the call going forward. So once we have that sorted out, we'll provide the updates and information. So the other ways to get involved in the Zcash community, we have the Zcash Community Grants Program. We have the newly formed Zcash Minor Grants Program. If you're interested in the Minor Grants Program, Jack, Gavin, again, and I are having a Twitter Spaces this evening to discuss the genesis and the purpose and how it differs from the Community Grants Program. That's going to be at 2200 UTC time. We also have the Filecoin and ECC Grants Program with the website up to see what they're looking for and what RFPs and RFIs they have available. You can join in the discussion via the Zcash R&D Discord. So if you click on that link, that can be shared in the Arborist call notes on the YouTube channel, you'll be able to find the discussions where all the members of the Zcash community convene to discuss development efforts. And then we also have the public Zcash community forum where we have other discussions in a more long format as well. So I'm going to pass it over to Billy, I believe, to do the Zebra update. Thank you.
Yeah. Hi, everyone. I'm Billy, the engineering manager at the Zcash Foundation. I'm here to give you an update on where we are with Zebra today, well, as of today. So we finished the basic implementations of mining features in Zebra. And a number of the team have been reaching out to mining pools, trying to find out who's interested in testing and supporting them if necessary. So if anyone watching is running a mining pool or is a solo miner and is interested in testing out Zebra for mining, please let us know. We'll get someone assigned to you to guide you and support you if necessary. Other than that, during the past few weeks, so last week and this week, we've had a bit of 20% time break, we like to call it. So we've had the team working on projects related to Zebra that are close to them, that they want to work on, and we're going to be releasing a number of blog posts over the coming weeks on what the outcomes of those projects have been. Finally, we have just received the first stats update from the team that is doing the audit on Zebra, and we have started creating some issues based on the findings. So yeah, if anyone's interested, keep an eye out for those. And I think that's everything I wanted to say today.
Awesome, thank you. Any pressing questions that can't hold until the discussion section of the call? Amazing, awesome. Move forward. Anyone?
Thank you.
Anyone? Oh, awesome, thanks. Anyone from ECC Core want to provide an update?
Hello. Sorry, I was stretching. Right, so updates for the last couple of weeks. The main thing we've been continuing on with is like initial preps for DagSync. So that's the main tasks there at the moment are still like, you know, getting through and reviewing all the precursor work you know, over in incremental Merkle True Create and stuff like that. We've also we did I don't know if I mentioned it in the last call, but we did some work around an issue that had been found in 32-bit on 32-bit usage of Halo 2 for orchard proofs, and there was an issue in terms of how the circuit was getting laid out. So we finished resolving that issue. The various branches are, I think we're just at the stage of, we've got a couple of crates to publish further down the stack. And then once that's done, then that fix will be rolled through into the next series of Zcash Rust crate updates. So specifically Zcash primitives 0.11 and crates related to that will contain those changes. So anyone who is downstream depending on them, so like the mobile SDKs, Y Wallet, Zingo Wallet, the other ones that I'm aware of that are somewhere downstream from our Rust crates. In particular, I think the common dependency for most of them is the Orchard crate. The next release of the Orchard crate will have those fixes in it.
Yeah, and that affected 32-bit platforms and also would affect newer versions of Rust.
Exactly. So this will also address
I think it's 169 and later.
170, I think, is the one it would land in, because it was in the changes that then got into the beta around the 169 release, and so there's a delay through there. So I think it's 170 onwards.
I thought I tested it and didn't work with 169, but
okay,
anyway.
it might have been 169 then. In any case, the point is that any Rust version from 156.1 on through there was fine, but yeah, the newer stable version would have affected 64-bit platforms as well. So yeah, we're basically about done with that. And so the main things there are just that that will also come in with the latest updates to some of the underlying crates. So we're just at the moment waiting on the next Red DSA release, which will then also filter into that same Orchard crate release. Nathan.
So when I heard about this, I was concerned about the potential for impacting consensus. Can you describe, so the platforms that were affected, if those were like doing consensus validation, would that have been a potential consensus bug?
In theory, yes. However, the specific problem was that a part of the layouter within the circuit logic was depended on some unstable behavior of an unstable sort function. And so the effect of that was that if there was a change there, it would result in a different verifying key. Now, unlike sapling and sprout, the verifying keys for orchard can get derived on the fly, which is an advantage both because we don't need to download these fixed parameters, we don't have the trusted setup, and that we can easily roll out changes if we need to in network upgrades. But there is still a consensus issue of people need to agree on what those verifying keys are. And so what would have happened if anyone had encountered this problem is that the moment the very first orchard transaction ended up on the main chain months and months ago, a split would have occurred. And a very noisy split at that, because no orchard transaction valid on one side would be considered valid on the other. It's not like a if there were a hypothetical problem in the circuit where it was under-constraining, for instance, and allowing more witnesses to be considered valid than we intended, that would be a significantly more problematic split. In this case, it's essentially a mutually incompatible change. So the fact that no one had observed this until now is a very strong indicator that there is no consensus problem here, because no one runs consensus nodes on 32-bit platforms. The only time that we had observed this thus far had been in either the 32-bit platform, 32-bit wallet, which was I think it was an Android 32-bit device, or as Dara said more recently, a change in the Rust compiler. And that would have also been noisy, because the moment that, for example, we tried to upgrade, because Zcashd, we keep it on as close to latest Rust as we can. The moment we had tried to upgrade that to latest Rust, we would have encountered the problem immediately as well. So it wouldn't have made it out into a Zcashd. Yeah, so it would not have made it out into a Zcashd release and caused consensus problems there.
And just one other quick clarifying question. So it did affect proving on a specific platform that was discovered by a wallet, right? And if proofs don't match consensus validation, that's fairly safe. That's safe for consensus. It's just bad for that wallet, and they can just fix that bug, and that's what we've done.
Yep.
Okay.
Yep. Exactly. The effect of it is that the users of those particular wallets who have funds in an orchard address were unable to spend those funds because the transactions they were creating were considered invalid. But there was no loss of funds issue. They can, once the wallet upgrades to a version that is able to create proofs again, they will be able to continue spending funds.
Chris has his hand up.
Yep. So the other thing that I wanted to mention for core team is we are almost complete with a major overhaul of the internals of the Zcashd wallet in terms of how it goes about constructing transactions, and that is going to also roll out in the next release, and it's going to that is going to include support for ZIP 317. In the Zcashd wallet, and we also are working through the last bits of the ZIP 317 support for the Zcash miner block construction code. So that's all going to be coming soon in 5.50.
Yep. Yep. Just working through final reviews of those pieces. Yeah, I think that's everything.
Okay, awesome. Thank you so much. Moving on to research and implementation status updates. I'll pass it over to Conrado for Frost updates to start.
Yep. Hi everyone, can you hear me? Can you hear me? Yeah, okay.
Yep.
So about Frost, we went through another round of review for the RFC, right? It's in the final stage of approval, hopefully, and received a review from the CFRG chair. It was a good review, mostly about editorial issues that we are addressing. Hopefully we'll get everything fixed this week, and then we can hopefully proceed to the next step of the approval pipeline and get the RFC approved soon. And regarding the implementation, Natalie has been working mostly with adding support for recovering shares in fraud. So if someone loses their share, they can reach out for the other participants and they can help. This participant recover the share, which is a very useful feature. We also.
So I didn't quite catch that. Can you say that again?
Sorry, about the recovery shares. Yeah, so we added a feature to allow a participant to recover the share. So this works by this participant reach out to the other participants, and there's an algorithm, a protocol that's run, and they help this participant recover the share. So of course you need to.
Oh, right, I see. In case they've lost it, yeah.
Yeah. You need to, of course, reach out to at least the threshold of signers to help recover the share. But it's done in a way that you don't need to actually recreate the entire secret. You just recreate the share that was lost. So
that's very neat.
Yeah. And also in parallel, we're kind of planning the work to do like a demo for Frost, a program that allows you to actually create shares and do the signing, both to exercise, for us to verify if the flow of, using Frost is good, if there's anything missing, and also to serve an example for developers to use Frost. And we're also studying and planning, implementation of broadcast channel, which is something that is required for the key generation, both in the trust dealer generation and the DK distributed key generation. So you need this broadcast channel, which is a whole thing, multi-party communication, and it seems they're using like a very straightforward implementation of it. So we probably work on that also. But we are on the planning stage for that. That's it.
Awesome, thank you. Are there any research updates from ECC? I'm going to pass that to Nate.
Let's see. The only update is I've spent a little bit of time talking to various people about where a good async forum would be. And so it sounds like the best possible candidates would be the Zcash community forum or potentially GitHub discussions. I haven't used GitHub discussions very much. So if people have opinions on that, let me know.
There will also be an update of the Zcash protocol spec and zip 216, mainly to indicate that it's possible to apply zip 216 respectively. This is the fix for canonical code points, canonical point representations. And some of the minor fixes, mainly to sapling in the protocol spec.
Yeah, so I think that's it for me.
And then I don't want to put you on the spot, Vivek, but I know you joined today's call from QEdit. Did you guys have anything from an update perspective, or are we all good there?
Yeah, I did. Chris have his hand up? Is there something pending from Chris?
I think that was.
Okay, if that's fine, then I have a quick update from Gedit, and so like this basically we've been having, like I think I mentioned in the last meeting that we've been having the meetings to like finalize the zips, and I think that's been making decent progress. We did some like internal backend changes to the asset identifier, the way it was defined, and like there's been some slight renaming of the thing, which has been completed in the zips now. And we came up with, like, we discussed some about like how we do the derivation of the issuance keys, and we are now like following the procedure that's done in zip 32, like analogous to the Orchard key generation. But completely independent in that it's not connected to the orchard keys anymore. And yeah, one of the other issues that was there was the split note discussion that I think we still need to figure out whether we wanted to use the split notes for the Zec notes as well going ahead instead of using dummy notes for that. But I think there were possibly some issues that we had to check whether it was fine to do so or not. So I think that's one of the pending issues over there.
I was going to review that and I just haven't had time.
Yeah, yeah, that's fine. Yeah. So on the implementation side, we've been doing work on the circuit side of things, and I think the most recent effort there has been on implementing variable-based scalar multiplication for the value commitments, because earlier the value commitments were with a fixed base, but now we need different bases for the different asset identifiers. So that's, I think, the major thing going on the circuit side. And on the client side, we've added issuance RPC commands, and I think the changes that we made for the asset identifiers to asset base, those changes we've included as well in the on the client side. Yeah, on the other hand, for future directions, we've also at Gedit, we've been thinking and trying to work out on some details for a continuation proposal for ZSAs to maybe including atomic swaps and the other NU6 stuff. And we've I posted some of these ideas a couple of months back, I think, in the forum. And yeah, hopefully we will have something more concrete out to show you all soon. Yeah, that's it for my update, I think.
Awesome. Thank you. Are there any other updates regarding research or research from the panelists here before we move on? Okay, great. So now we're just moving into open discussion. So if there were any questions that anyone had from the content that was presented today, we'll give anyone the opportunity to ask and potentially clear things up, or just have a discussion around the content we heard from today. So we'll pause for a moment and see if anyone has any questions. Okay, awesome. So
on the I do
sorry.
actually. So on the subject of Zcon 4 and particularly COVID precautions for Zcon 4, do we have any more information about what those will be?
No.
Okay. That's a clear answer so far.
Any other questions or comments on the previous question? See, Addy. Yep, go ahead, Addy.
ETA on the Zcashd v550.
That's likely at this point to be 3 or 4 weeks away, I think. If you look on the developer DAG, which I'll paste in here again for everyone's benefit. Where's the chat? Here we go. If you look on the developer DAG, you can find the release 550 node within that DAG. Everything upstream of that is the stuff that we are currently aiming to get into 550. You can see that for example, there's the Halo 2 32-bit fix that I mentioned, and then there's the zip 317 stuff going in. So that will essentially, the moment we've done all that is when we plan that release to go out. And currently we're expecting that to be 3 or 4 weeks from now.
Sounds good. Thanks.
I had a brief question about the about the Frost crates themselves, that side, because I know, Conrado, you'd said in the Discord that that you're planning a release of that side soon, but just I'm sort of wondering what the current status overall is of them in terms of like will that be just like basic type support and thing there, or are they getting close to people could start looking at using these in downstream systems?
Yeah, we've just pushed core and re-randomized like half an hour ago, more than half an hour ago. So those are up. Those are every Frost thing is going to be 010, even though they've been in, you know, various forms of development for well over a year, mostly because the spec is not finalized.
Yep.
We do not foresee any major code changes to affect the API or any significant changes underneath the API level from editorial, you know, going through the final bosses of IETF editorial, blah, blah, blah.
Yeah, it's unlikely that will occur at this point. Yeah. I was more meaning in terms of like the network protocols and stuff like that. Are there any changes expected on that side in terms of what the Frost crates implement, or do the crates not currently implement those and just focus on what goes into the RFC?
Yes, they're just focused on the RFC. The Frost crates are like the pure cryptography of creating signatures and creating keys to make signatures and verify them with. The stuff about like you need a broadcast channel to do DKG is in a different area. That's like a different layer of the abstraction.
Cool. Thank you.
Yep. And we don't foresee the serialization of these types. So when you are eventually putting them on the wire or putting them on disk or whatever you're doing with them, to significantly change out of any of the IETF updates.
Cool.
Conrado.
Yeah, just to be clear, so the reason there is dependency because we added support for re-randomized Frost in RedSA for RedJubJub and RedPalace. But of course, this is a work in progress since the Z312 is being reviewed, so it's not done yet. So it's just, you know, a proof of concept. I mean, it's working, but yeah, it's not done yet. And this feature is gated under the Frost feature, which is disabled by default. So users of RedSA shouldn't be affected, but we had to publish the dependency in order to publish RedSA.
Yep, yeah, that makes sense. So from our downstream perspective, for the moment, it is an experimental feature. Then from the perspective of users of the RedDSA crate and Orchard and so on. Cool. Okay.
On just a related question, you know, is ECC planning to implement Frost in either Zcashd or the upcoming ECC wallet?
Speaking to Zcashd, not at present. I mean, we have RPCs inherited from Bitcoin for doing like transparent multisig, and it would definitely be interesting to look at how to implement something similar for shielded. I suspect though, with the way that the RPCs and things are set up, it will be, shall we say, slightly more painful to use there. And I personally would advocate for that kind of thing to be done outside of Zcashd. If there were places where people wanted to be able to have a have one of the shares or something in Zcashd for whatever reason, then, you know, we can discuss that bridge when we come to it, or in my case, burn that bridge when we come to it. But I suspect the thing that we would want to figure out before then is something probably along the lines of like the work that I was doing years ago on partially created Zcash transactions, PCZTs, or something like that, to a Zcash analog to like the PSBT work, partially signed Bitcoin transactions that Bitcoin has sort of moved towards. for basically how do you ship around things that are not actually typed as a transaction yet, to shift between things. And obviously Frost solves this specifically for signatures, but there's various other elements of that to the transaction that we'd need to figure out, I think, before something would be suitable to go into Zcashd. But a bunch of this stuff can be implemented in separate binaries far more easily, I think.
Yep.
And the new ECC wallet?
Just gonna speak to that. So the first version of the wallet is going to be super rudimentary. So what we're doing is we're like stripping down functionality as much as possible and just having basics. And then what we would like to do is deploy it, see who uses it, and then start developing support for use cases in a more rigorous way. So using Frost would be a potential if we like identify a specific use case and like work out the usability and so forth for that. And I would like to learn more about what like different user stories would be that would use Frost. It's something we would definitely want to look into. Because we're especially interested in ways to remove sharp edges with respect to managing secrets and keys. So we're curious about things like social recovery. So it's an area we want to explore, but we have no specific plans on our roadmap.
Okay, great. Deirdre, you have your hand up?
Yeah, we would love to have conversations with anyone, including either Zcashd dev team or ECC new wallet team or anyone else, about how to do Frost, which is just the signing part, versus doing the key gen part, which have different requirements of how to do them securely in practice. For depending on your deployment environment, just doing signing and sort of leaving the key gen out of your main application or your main wallet or something like that, or at least the first part being signing and the second part being more complicated key gen, may be easier. If you do trusted key gen, that is also slightly easier than the hard mode of DKG, distributed key generation, which requires some sort of broadcast channel to do it securely. For Zcash, for people with access to a blockchain, you may have different options of how to do that, the attractive DKG ceremony, than other parties who may not have that available and may need something like the broadcast channel toy that we're going to demonstrate as like a way to do that if you don't have one of those things. So please, if you're interested, come talk to us people working on Frost, and we can kind of help suss out what your limitations are, what your requirements are, what you have available to you. And as opposed to being like, go use our library, this is what you must do to do DKG, because that might not be true for you.
Nate, were you first, or was your hand still up?
Yeah, my hand is still up, so I'll just do this quick. So there is a community wallet developers meeting that meets every day. This slot meet, so it's every 2 weeks. And I think it would be awesome to, if anyone wanted to give a presentation on what Frost is for all of the wallet developers, because they might be the ones that would be like building consumer-facing applications using it. And I would definitely like to see that presentation too. So just a suggestion.
Yeah. As just because we're here and talking about it, one of the things that I've really wanted for a while for Zcash is the ability to locally do the same kind of 2FA that I do with my websites. And an app that I think does this very nicely for Bitcoin is Casa. And they have various things you can do, and various things that various ways you can set up. But theirs is built around just regular Bitcoin multisig. But the idea essentially of you don't need to worry about the DKG or broadcast medium also as much, because you are the dealer. Like when you set up your wallet, your local device is the thing doing the dealing, and then it's just so that would conceptually setting that up is a lot simpler to do, because your medium is just like, okay, you're connecting to this hardware wallet, then this hardware wallet, or whatever your signing devices that you're tying it to. And then obviously when you're doing signing, you're just like, okay, you need 3 of 5 devices to be accessible to be able to spend funds in this thing or whatever. So I would really like to see someone pursue something like that as a use case, which sort of gets away from the I need to deal with like some other party on the network or whatever. I mean, there is still like, I think Casas has that option of like they can be a backup share as like an emergency backup, but again, like that's entirely within their ecosystem, so you don't have to worry as much about like doing DKG over the blockchain or something like that with arbitrary people.
Yep.
Sort of simplifies the problem a bit.
Yep. That's kind of like the standard recommended-ish deployment of like the easy mode of doing Frost is a trusted keygen with dealer, and then you just hand them out however you hand them out, and the only requirement is you make sure that everyone can see the same commitment to your secret polynomial and that everyone can verify it. That's slightly easier to do than doing the full multi-round DKG ceremony.
Yeah.
And yeah, you can just hand those out as long as you can all see the same commitment and everyone can see that they're all seeing the same thing.
Yeah. And for this kind of thing where your trust model is you're trusting the device you're setting this up on at the beginning, but you're not necessarily trusting its security in future, that model seems fine. I mean, you could also, if you wanted to secure it more, you could still run the DKG style thing between the hardware devices if you trusted the hardware devices more than the machine you set it up on. But yeah, there are definitely levels to how paranoid one needs to be.
Mm-hmm.
Sorry about the background noise. Zero Darts in the chat has asked if there's any updates on ZIP 317.
Chris gave a note on that earlier in the call. If you like, the recording will obviously include it, but the short of it is that Zcashd is working on like the next the 550 release will have Zip 317 block production and Zip 317 fee selection in Zcashd's block generator and wallet. And once that's out, then we'll be looking on the mobile SDK's side at enabling it on that side, because it's deployed and ready on that side. It just needs to be enabled. And then I think Zebra had said in a previous call that they basically already have their block production set up to do Zip 317, and they don't have a wallet. So with 550, that should mean that all the pieces are in place.
Yeah, all of the pieces. So with respect to the mobile SDKs, all of the pieces are in place for use of Zip 317. It just needs to be enabled. And for the wallets like Zec Wallet Lite and I think Y Wallet that don't use the SDK directly, all of the pieces that they would need to use to do the Zip 317 implementation are available in LibreZcash. So they should be unblocked. And if anyone has anything else that is needed from the LibreZcash side, they can let us know.
Awesome. Thank you guys. And any other outstanding questions before we wrap up today's call?
I have a
Sorry,
small
Deidre.
list. So we're starting our Zebra audit, and one of our auditors, before they started investing a lot of time in testing Zebra, was asking about Zcash support or historical analysis of Eclipse attacks on the network. And so I basically wanted to ask the Zcashd team if they had previously done any analysis to whether we wanted to invest at like a full Zcash network level about protecting, mitigating, or doing any sort of defense against these sort of network level Eclipse attacks, you know, attackers segmenting parts of the network, isolating nodes, that sort of thing. Because we basically just wanted to remain compatible and as in line with the, you know, general behavior of a compliant, compatible Zcash full node, a peer-to-peer node. So I wanted to ask about any of that sort of history, if there's anything that you've like looked at and rolled out, or you're like, it would be nice to do this, but it'd be too complex and complicated, or we don't have time, or any of that sort of thing, before we tell our auditors, like, go for it, like spend 3 weeks to you know, set up a ZebraD testnet in a box before, you know, before we even know the history.
Yeah. So Zcashd has some complicated code in the address manager to kind of bucket addresses by subnet, essentially. It's a little bit more complicated than that. And I honestly don't know how effective that is. There's stuff that kind of just accreted in Bitcoin Core as they got attacked in various ways. But Zcashd still has that. Do you implement anything like that in Zebra?
Not by subnet, I think. We basically look at address behavior of like how they're connecting to us. But we're not, I don't think we have anything that's looking at just where the address is supposedly coming from, and things like that. I don't think we have that right now.
Okay,
I
don't think so. So I hadn't seen anything like that in the code.
Yeah.
Like I say, I don't know how effective it is. The intuition is that if an attacker is coming from some subset of the IPv4 or IPv6 address space, then you might want to prioritize disconnecting sort of connections that are all coming from kind of the same place, if there are too many of them. But it's all a bit heuristic, and I've never seen a design document that gives a clear rationale for all of the design decisions that were made there.
Yeah, it's definitely more upstream accumulated things. And we also have our networking stack is upstreams accumulations as of somewhere between 0.11 and 0.12. So they will likely have a bunch of other things they have done to the network stack over the years that we also don't have. So we are not mitigationless, but we also aren't. There are likely things that one could try and do. That being said, we definitely have an easier time against Eclipse attacks than something like than a pure peer-to-peer network, because we have the shared global state of the chain, which individual nodes will checkpoint and confirm that they're getting the correct view. So it does become like all you need is a single external connection that's beyond the Eclipse to be able to have a chance at finding the and reconnecting to the main view again. So it's not that we shouldn't think about it, but that we are likely a little more resilient in the face of that than pure DHT-based peer-to-peer networks, for instance, would be.
Okay.
Yeah,
Okay.
I mean, for any auditing, there's a trade-off between if you look at a particular area in a lot of depth, then what other things are you not spending your time on? It's up to you what you want to audit. But my suggestion would be that maybe other areas are a higher priority.
Yeah. I mean, that being said, if they have downtime and there is time that you wanted to spend on it, then I wouldn't think it would be a waste of time to be looking at, okay, are there mitigations that that Zcashd currently implements that Zebra not implementing creates a detriment to, for instance.
Yeah.
As opposed to necessarily there are mitigations that neither ZebraD nor Zcashd implements that would help overall. I think that kind of thing would be useful, but whether it's useful for specifically the audit that you're doing is a question for you.
Yeah, what kind of experience do these auditors have? Are they mainly on the cryptographic side, or sort of network protocols in general, or
a little bit of both? A little bit of yes.
Okay, can you say what auditing firm it is?
NCC.
Ah, okay, yes. Yeah, good choice.
They know what they're doing.
They do.
Yeah. It's quite lovely because we're like, cool, you know a lot of this stuff, but here's a completely new code base. Tell us what we did wrong.
I bet it's quite fun for the auditors. I'm almost jealous.
They haven't run screaming yet, so yay.
The mitigation that you guys mentioned of like dropping peers that are on the same subnet, that seems to assume that the attack will be coming from the same subnet. I think that might be a fairly.
It's not specifically dropping on the subnet. Dara gave a general overview. There are the key thing that it's doing is it actually terms them groups, I believe, in the Zcashd code base. And the heuristics for how the groups are defined and split up is more, significantly more than just a IPv4 subnet or whatever. I believe, for instance, the where you learned an address from plays into it as well. So for instance, if like one of the effects of this address manager bucketing system is that if you hear about an address from multiple different people more often, you're more likely to try and connect to it. Because the fact that you've heard of it from different sources, I think it still ends up in either the same or like the similar like subgroup. But like the bucketing system at least will put it in more buckets, so you're more likely to come across it. But the specific thing I'm thinking of is regarding outbound connections. The node will not make more than one outbound connection to any particular grouping for that definition of how the groups are set up. And a lot of that is just basically to be like, we don't want external we don't want data coming from inbound connections to solely determine what our outbound connections are, put it that way.
Yeah, that rule in particular does make sense, and I think has a sound rationale. Obviously, anyone can pretend to be from anywhere in IPv4 and IPv6, but to the extent that sort of ISPs do egress filtering and stuff like that, it does make it a little bit more difficult for an attacker.
Yeah, and at the end of the day, if your node is the one who's choosing to connect out to something, it's the one who then gets to choose why it connects out to them. You got the IP address from an adder message from a peer versus you got the address from a DNS seeder versus you got the address from a hard-coded list that the developers gave of some trustworthy nodes to start off with, for instance. I think Zcashd inherits all three of those approaches from Bitcoin, although we don't do the hard coding. Well, no, we do hard code like a couple of trustworthy nodes like mainnet.z.cash. but purely as you reach out to this peer and it's as a starting point, and then you'll learn adder messages from that peer that you can then use to find other peers and so on.
It sounds like these protections are something we'd want to implement in any new DNS seeker, doesn't it?
It is the kind of thing that even the existing DNS seeder does. The existing DNS seeder has a bunch of heuristics it uses before deciding to give out IP addresses, and one of those is, okay, it's following it appears to be following the network protocol properly. It's checking that versions are compatible. It's checking that that heights are compatible. That it's online and behaving correctly over an extended period of time and stuff like that. And yeah, you can put whatever additional heuristics you want into that DNS seeder to try and filter out nodes that don't make sense to give out to general people to connect to.
Yeah, I mean that's largely a reliability thing rather than a security thing, because obviously an adversary can appear to be a perfectly compliant and reliable node. Yeah.
But the key thing there is being able to give out a bunch of, and so I know the CDNS seeder, it also buckets what it gives out. So if you request IP, if you request if you have a DNS request coming in from a particular IP address, it will give out the same set of IPs to you if you do repeat requests within a certain time window. So to limit the ability of people to enumerate the full set of IPs that a seeder is aware of, for instance. So again, a lot of these are just heuristics, and we don't know in practice exactly how well they work, but yeah, they definitely don't hurt.
Yeah, this reminds me of an issue that we had at a certain bank I worked with, where there was discussion about our disaster recovery approach, and the fact that both our primary and our alternate recovery site were in the same city kind of raised the question: well, what happens if the city is hit with a nuclear bomb? And the answer was, well,
you might have some other
if that
problems.
happens, I think the markets are going to be screwed anyway. So yeah, I think that unless there's reason to believe that Zcash is at a particularly more vulnerable to these sort of attacks than other chains, for some reason, I think we'll probably deprioritize this for now, and then maybe certainly think about it in the context of a new DNS seeder. Then maybe just stick it as a future tech debt thing to review how Zcashd does it, and therefore whether we should replicate that in Zebra at a future point.
Yeah, it's also the kind of thing that
I wouldn't quite say that that some of these mitigations don't necessarily hurt, because it is a lot of code complexity.
That is true, and also the other aspect to consider here is that some of this may time out if there is a move to proof of stake or some other system that ends up being a move to a some or all of a significantly different network protocol or a different network interaction setup. May obviate some of those things, or give us a whole new set of problems that we have to deal with in that context instead.
Yeah, that's a good point. Really good point. Thank you.
I've got two other queries.
You have a very good memory, Deirdre. I'm impressed.
Do I? I wrote them down. I don't have a good memory. I wrote them down. I have a researcher who is interested in doing, they did some work, and I said, hey, could you do something like this for Zcash? And they were kind of asking me some questions. They're like, well, does Zcash, writ broadly, fund PhD students? And so we have community grants, we have minor grants, we have lots of grants floating around. And I was wondering if there is if those are the correct avenue to say, have a researcher look at the Zcash protocol as it currently stands and doing some sort of security analysis in the way that they have done it for other work, because I need them to get back to me to be like, is this one grad student for a year? Is this one grad student for 6 months? Like, how much money? Is this a minor grant size? Is this a major grant size? I have a feeling it's slightly larger than a minor grant, but slightly smaller than some of our major grants. But I wanted to throw that out there if that's the appropriate avenue for some of this work to be done for Zcash.
Yeah, I would say that you know, depending on how much they're looking for, then minor grants, bearing in mind that the deadline is coming up in 11 days, or major grants, the aka Zcash community grants, would be a fine. But I would like, I think maybe their starting point would be to post some ideas on the forum and see what sort of feedback they get.
Yeah. Okay. I will guide them towards major grants, and I will help try to guide a post and submission. I don't think they're based out of Europe, so I think they would have to lean towards a major grant versus if they were in the US, they would be able to patch together funding from minor grants and other things. Great, thank you. And then the last one is I had another researcher who was asking about Halo 2 and saying they would like to implement Halo 2 in like a formal specification language sort of deal. And they're like, is there a Halo 2 spec? And I'm like, the code and the book, smush them together, that counts as a spec. But is there any movement on that, or anything that would help them try to re-implement Halo 2 so that we can prove certain things about it in a different way?
So we do have that. It's section 4.2 of the book, the protocol description. The thing that has the security argument. That is the formal description of Halo 2, the proving system. Is that actually what they want to implement, or is what they want to implement plonkish?
Both.
Okay,
Sounds like
so
both.
the formal description of the proving system definitely abstracts over some of the details of like the plonkish representation. So so for those we would need to look, like there is a description in the book. I don't know precisely exactly how, like section 1.2, I don't know exactly how closely it matches exactly what we implement, but it's reasonably close, I think. In terms of the AI,
it's not described to the same level of detail as the protocol spec does. So yeah, I think if you wanted to do an independent implementation that is compatible with Halo 2 proofs, then it's feasible. It's a lot of work, would require some social engineering, reverse engineering. Sorry, I was probably social engineering to get us to spend our time in it. But I am happy to help anyone who's doing that. And in addition to that, there is an effort by Mary Muller and some of us to standardize plonkish, and whether that ends up being interoperable with Halo 2 as currently implemented, I'm not sure, but it certainly would help, and would be of interest to the person doing that project, I think.
Yeah, I think the way to maybe frame it right now is, if you want to be compatible with like the Halo 2 proving system as one might write in a paper, then section 4.2, the protocol description for Halo 2, is the place to look at. That is the protocol description that matches the proving system that is deployed currently in Zcash. There are changes that will be made to it as part of like, recursion implementations and yada yada, that sort of stuff. But like what we currently implement is described on that page. If what you want is to be able to
modular potential errors.
Exactly.
I don't think anyone has completely reviewed it against the code to check that everything is exactly as in the code.
We definitely did some checks.
We have done that
for
the rest of the protocol, but we haven't done that for Halo 2.
Yeah, I think we did do a bit of that at the time, but like I remember doing reviews on things and like tying them into so I did do some of that review, but I didn't have the space at the time to fully tie it to all of the mathematical things. I was relying on Mary, who was reviewing the page itself and the proof and security argument itself to for that. But yeah, it is the closest thing that we have there. But I would also say that right now, trying to write a formal version of Halo 2 is probably like trying to do the same thing with GCC.
Oh no, that's way.
Okay, shall I say Clang instead? Would you be less adverse there? My point being is
no, because we know how complicated it is to produce a formal model of C, because we have one. There is it CompCert, something like that. I can't remember what the project's called, but we have a model of C and it's huge. So I think Halo 2 proofs is nothing like as complicated. Or
I don't think it's nearly as complicated, but what my glib statement was trying to imply is that currently Halo 2, with its arithmetization and things, implements an informal model in that it tries to describe conventions and guide people down particular registers of like ways to convey their circuit intentions into code, and give them as many safety rails and things as one can. But it is still done in a bit more of an ad hoc way, with things that we developed and improved over time, rather than being something that is designed to be explicitly modelable. So it may still be modelable, but there may be things that are made trickier by the way we currently do them, because our goal in doing them a particular way was user safety and circuit performance rather than being modelable.
Right. Yeah, my impression was that this person wasn't trying to prove correctness of the Halo API is currently implemented. They were more trying to give a model in the specification language.
Yes.
Yeah.
That could be compared against
like,
the implementation.
Like HackSpec. Like they're
Exactly,
trying to kind of use something like HackSpec or a version related to HackSpec to implement in a high level specification language Halo 2 all the way down.
Yeah, so definitely the best place for them to start would be the protocol document section 4.2, and then beyond that they will likely need to look at the code and ask us questions.
Do they have access to the Halo 2 Discord?
I think they do.
I think I pointed them in that direction, but I don't know if they've gone there yet.
Actually, this is now ringing a bell. I'm wondering if this, I remember seeing someone recently posted somewhere about something similar, and I'm wondering if this is actually this person. It could easily be. I will have to go hunting through the channels and try and find where that was.
If not, then please point them there.
Yeah.
Halo 3 is not a thing, I think.
No, Halo 3 is not a thing. Halo 2 is technically not really a thing per se. The reason that it's Halo 2 is because Halo was a proving system protocol defined in a paper that didn't get published other than on ePrint, but like the thing that we implemented in the Halo 2 repos is not the thing that is implemented, the proving system implemented in the Halo paper. This is actually the same problem that people had with the word plonk, with the name Plonk, because Plonk means several different things, but foremost it means the Plonk proving system defined in the Plonk paper, which is much more limited than the things people actually do with what people now appear to have coagulated around as Plonkish arithmetizations on top of various different proving systems. So Halo 2 being called Halo 2 does not imply that there will be a Halo 3. more likely Halo to the ecosystem of crates and proving systems and things will be expanded based on what its users, what its use cases evolve into being. And one of the nice things about it is that we can do those kinds of evolutions in a way that people can migrate to, because you don't have to run a new trusted setup every time you change the circuit. So it's more about if we're making changes, we make the changes in a way that people can follow them rather than being stuck.
And Halo 2 with recursion will still be called Halo 2. And if we add things like dynamic lookups or I'm not sure about adding support for things like hyperplonk, that might be called something different, but yeah, the library will continue to be called Halo 2.
DLC.
Halo 2 comes with DLC.
Yes.
So to do that, would, if you were to support hyperplonk, that, like, how much work is it to support 2 or more different arithmetizations at the back end?
A lot of work. The initial generalization to make it support 2 is where the hard work is.
That's really
kind of what I was wondering.
That work is work that I want to have happen, because it's also work that we need for things like other DSLs or compatible intermediate representations and things. And that's really where I was thinking in the direction that something like this research project might end up in, is being something that can it can be a specification that is compatible at some particular intermediate representation, for instance, as being the layer that translates to, which what I mean is that would then enable taking out some of the complexity of like precisely how certain optimizations are done in our stack and stuff like that. We'll see. But in any case, the various things going on, like the Plonk-ish standardization effort, for the representation, or the various other IRs that people have been working on, to try and make progress in this space. One or more of them is going to end up being in Halo 2, but the work to get just one of them in is the big lift.
So speaking about that Plonkish standardization effort, so we realized that there's a different way to think about rotations that might be sort of more amenable to analysis and more amenable to optimization than the way that the Halo 2 library currently does it. So this new way is to think about abstract columns. So whenever you would reference a cell at a non-zero rotation, instead you represent that as an abstract column, and then you have hints that map the abstract columns to rotations. And the advantage of that is that you can compile it in one of 2 ways. You can just take the abstract columns literally, and that produces a valid circuit without rotations, or with only 0 rotation, or you can use the hints to to compress the circuit area.
It's an evolution of the optimization ideas I outlined in my ZCon 3 talk. So there was a slide there where I talked about different ways you could write equivalent circuits. And the nice thing about this is that the thing that the rotations are effectively doing is encoding intent from the circuit designer, which is the thing that you're really missing if you're just trying to do these optimizations from scratch. So treating them as hints may be the right way to meet that abstraction. But anyway, I think this is going a little further than Arborist call really needs to go. We're definitely getting into the weeds. So
it is the advantage of this is that the hints can be completely arbitrary, and it doesn't change the meaning of the circuit. So that they could be completely wrong, and the circuit would still that wouldn't create a correctness problem.
Does anyone have any other topics before I ask another question? But my list of pre-planned questions has been completed. Looks like No, but okay. Rule back of the envelope calculation. What is the performance space differential between the lovingly handcrafted compilation down to Plonkish that you have created for Halo 2 versus compiling to some arbitrary IR that's kind of on the market and using that to compile down to a full proof to be verified?
Rough top of my head estimate 3 times.
Wow. So abstraction comes with a cost.
Well, okay.
Thing is-
It depends how good the compilation is. I
Okay.
firmly believe that you can do something like just a 5% overhead, say. You might not be able to automatically do some of the things we do. On the other hand, so for a given time budget in how long you have to manually optimize, a compiler might be that's a very cute doggy. You're distracting me. The compiler might be able to do better, just like it is in for just compiling ordinary code to a processor. If you have a lot of time to optimize assembly language for a particular instruction set, then yes, you're going to be able to do it more efficiently. But most people don't have that time, and in that case, the compiler will do a better job. No, not just nearly as good a job, actually a better job.
Yeah, the core issue, of course, is that we in the timeline of developing compilers for circuits are still a lot. We have been a lot earlier on in the process than code compiler toolchains have been. But like the end goal is something similar.
Yeah, we're kind of speed running the from the 50s to the 80s in terms of compiler technology.
Yeah, and I mean, you can also look at it for circuits in 2 ways. The nice thing about with a circuit is that this effort to do optimization only has to be done once at the time, before you pin the circuit, because once you've pinned the circuit, you're not going to be going and editing it beyond a well-defined common upgrade point, because everyone has to agree on the contents of the circuit. So what you can choose to do is write your circuit more abstractly and then just throw a butt ton of CPU power at it to SAT solve the absolute best layout or whatever, and however long that takes, you do it and you just pay it down once. But you need to have all the tooling in place to be able to represent your circuit firstly in a way that still correctly conveys the things you need. B, has a way to imply all of the various hints and things that you know of in terms of what you mean. Oh yeah, this type of, the type ranges and things are all correct things. And then C, knows about all the various tricks and things that thus far people individually have been figuring out for circuits and hand encoding. And yeah, that's a lot of work to get there. But once it's there, then everyone can benefit more easily. But on the flip side, you also have the thing where people can't choose different optimization strategies because they have to agree on the verifying key. So it's not like with regular binaries where 2 different people can choose, one can run in debug and one can run in release, and they will be, for the most part, compatible, because it doesn't matter if the precise binary bits in their 2 binaries differ. For the most part, even the undefined behavior isn't usually going to be accessible, or it's not going to leak its way out into the main protocol that the binary is implementing between the various parties. There are obviously notable exceptions, but usually those exceptions are limited to exploiting the person who is running a particular binary. Whereas with circuits, similar issues result in, no, you represent invalid state, and that breaks the protocol that the thing is encoding. So the option at the moment is just everyone has to agree on the same circuit. There's no way for different people to choose different things. So
yeah, it's those pesky proofs that get stored in blockchains. Blockchains are terrible. Why do we use them?
Cool. Thank you. I kind of knew some of this, but at the same time, I was curious.
Yeah,
how far apart we would be if we tried to make this kind of abstracted away, manage the complexity a little bit, reuse some of this. And it's like, one, there would be a gap, but two, it might help people eventually. But
yeah,
do we think, okay, one, do you think Plonkish is that we're want to stay with Plonk-ish, or would there be other arithmetizations that are more attractive for reasons? AKA, like, is there sense in trying to coalesce around Plonkish as a target?
Yeah,
and investing?
yes, because Plonkish has essentially all of the optimizations for arithmetizations that we currently know how to do. So you compare it with R1CS, it's strict improvement. If you can, maybe not for additions, but in practice it is. And if you compare it with Air, then the essential difference is that Plonkish allows equality constraints and Air doesn't directly. So yeah, I think Plonkish is here to stay. If there are improvements to it, which is quite likely, that then the things that we've learned from using Plonkish will still apply.
Cool. All right, I think I'm done with questions.
I have to go soon anyway.
Yeah. Yeah, I think the centralizing around Plonkish at the moment is it's sort of one way to think about it is that it gives the ability to, like, the tooling it gives you is the ability to work almost arbitrarily in additions and multiplications. And those are the two things that we have at our disposal when building protocols around fields and groups. So that basically gives you everything you need. R1CS was a little more restrictive in that regard, in that you had arbitrary additions, but you did not have arbitrary multiplications. You had to do them in a very specific way, which simplified the model, but did put limitations on how you could construct your things and how efficient they could be. Whereas now with Plonkish, that lets you sort of do arbitrary trade-offs in those two operations. Like the space is now sort of close enough to the protocol in terms of abstraction that barring some significant shift in the landscape, it's likely that most improvements going forward are going to be on the current theme.
Yeah, the only thing that so potentially you could argue might be a slightly bad idea in Plonkish is the rotations, because they make the ordering of rows matter. Actually, this idea for how to use hints helps with that, because in the version that uses abstract columns, you can reorder rows. So you regain that sort of analyzability aspect of it.
Exactly.
Awesome.
Awesome. Thanks, everyone. And then I think that's a good place to wrap up. We've been on for about an hour and 23 minutes. So everyone cool with wrapping up the call for today's Arborist call? Awesome. Well, want to say thank you to everyone for jumping on today, and want to just confirm or reaffirm that I'll be sending out some messages to confirm the new hosts going forward. And if there are any process change, but we're going to do everything we can to make sure that there are no process changes and all the call links and invites and everything stay the same. So I'll send an update within like the next 2 to 3 days on that.